Welcome to lesson 06. Today we're going to talk about multiplying probabilities. Some vocab terms to start off here. We've got independent events. So if we have two events that are independent of each other, that means that if one event happens, that has no effect on the probability of the second one happening. We also have dependent events, in which case if two events are dependent, that means that if the first event happens, that does affect the probability of the second one. Conditional probability, the probability of event A occurring given that B has already happened. So the second event we are assuming has already happened, so we're going to find the probability of the other event occurring now. We also have a two-way frequency table, which is also called a contingency table, and that shows the observed or relative frequencies, or how often, data from an experiment classified according to two variables, with the rows indicating one variable and the columns indicating the other. The first thing we're going to talk about is the probability of independent events. So if we have two events, A and B, that are independent, and again that means that the outcome of one has no effect on the other, then to find the probability that both A and B will occur is taking the product of their individual probabilities. So probability of A and B is equal to the probability of A times the probability of B. An example of independent events, so we toss a coin and we roll a die. What is the probability of the coin landing on tails and the die rolling a 3? So in this case, you'll notice that they are independent because it doesn't matter what the coin lands on. That has no effect on what the die rolls. So what we have here is we're going to say that event A is flipping tails and event B is rolling a 3. So the probability of flipping tails should be 1/2 because there's two outcomes that could happen, one of which is tails. The probability of B happening, probability of rolling a 3. There's 1 3 on a normal die and there are 6 total sides, so the probability should be 1/6. So if I want the probability of both happening, A and B, I should take the probability of A times the probability of B. 1/2 times 1/6, I should get 1/12 is the probability of getting tails and a 3 on a roll. Probability of dependent events. So if two events are dependent of each other, then the probability that A and B occur is given here. So it's a little different here. We've got the probability of A, and we're going to multiply that by the probability of B given that A has already happened. Okay, so that's what this bar means right here. A has already happened, so what's behind the bar has already happened. Find the probability of B. And again, we'll multiply it together with probability of A. So an example of that would look like this. So we've got a bag that contains 12 red, 9 blue, 11 yellow, and 8 green marbles. If two marbles are drawn at random and not replaced, what is the probability that a red and then a blue marble are drawn? The reason why these are dependent is because once we've chosen something, we don't put it back. Okay, so we'll go through this just like we did before. Probability of A, we're going to say is red, and then B is going to be a blue one. Okay, so the probability of A, there are 12 red out of a total of 40 marbles. And if we simplify that down, we can get that down to 3/10. Now, we've picked a red one. Now, when we go to the probability of B, there's not 30 or 40 marbles in there anymore because we took one of the reds out. There's only 11 left now. So when we're finding the probability of B, given that A has already happened, there are 9 blue ones. But now, if you add 11, 9, 11, and 8 together, there are only 39 marbles left because we took that one out. We can still simplify that down. We can take a 3 out of both, so we get 3/13. So now the probability that A and B happen, we take these two probabilities and we multiply them together. So the probability that we choose a red and then a blue is 9/130. Next thing we're going to talk about is conditional probability. So if A and B are dependent events, then the conditional probability of a B occurring given that A has already occurred is given in this fashion. So we find the probability that A and B have already happened, and we divide it by the probability of A. So here's an example of that. So at a restaurant, 25% of the customers order chili, 4% of the customers order both chili and a baked potato. Find the probability of that somebody who orders chili also orders a baked potato. Okay. So we have here chili is our event A, baked potato is B. So if we want the probability of B given A, we take the probability of A and B divided by the probability of A. So 4% ordered chili and a baked potato. 25% ordered just chili. So to find the probability that somebody ordered chili and then they also ordered a baked potato can be found by doing 0.04 divided by 0.25. And if we type that in, we get a 0.16, which we would say 16%. So 16% of the people ordered chili would also order a baked potato. So now we're going to talk about two-way frequency tables. So we've got an example problem here. We've got a drug company conducted an experiment to determine the effectiveness of a certain new drug. Test subjects were randomly assigned to one of two groups. You are either in a treatment group, who received the drug, or you're going to be in the control group, who received a placebo or a fake drug instead. In the next slide, you'll see the table with all of the data values in it. So as you can see up here is our frequency table. So we've got our one variable is our treatment versus control. Our other variable is whether their condition improved or not. So this number right here, this 1600, that means that they were in the treatment group and their condition improved. This 400 means that they were in the treatment group and their condition did not improve. Same with the 1200, they were in the control group, that condition improved, and 800, their condition did not improve and they were in the control group. Okay. Find the probability that the test subject's condition improved given that he or she was in the treatment group. So group A, or probability of A is the treatment group, condition improved is B. So again, probability of B given A is equal to the probability of both divided by the probability of A. So the probability of both, they were in the treatment group and their condition improved. There's 1600 total. And to find the bottom, we would have to add up all of these numbers together. 1600 plus 400 is 2000. 1200 plus 800 is another 2000, so it's out of 4000. The probability of A, so we just want to know that they were in the treatment group. There are 1600 and 400, so that would be 2000 over, again, the total of 4000. So now we've got a fraction divided by a fraction. Now generally we don't like dividing fractions by fractions, so in order to change that, we're going to turn that into a multiplication of its reciprocal of the bottom. So instead of dividing by 2000 over 4000, we're going to multiply by 4000 over 2000. When we multiply fractions, you'll notice 4000 should cancel each other out. And we've got 1600 over 2000. A couple of these zeros will cancel out. So I'm at 16 over 20. And I can simplify that even farther down to 4/5. So the probability that their condition improved, given that they were in the treatment group, should be 4/5. Okay, so that's one way to look at it. If you want to look at it a different way, we've got this same table here, and we're going to do the same thing. We're going to find the probability of B given A. Okay, so again, A is the treatment group, and B is that they improved. Okay, so if we know A has already happened, we know that they're in the treatment group, we can cross out the control group because we know they're not included. Okay, which means we're only looking at 2000 people. Okay, So out of the total treatment group, we're looking how many had their condition improve. Well, that's the 1,600. And you'll notice we get the same fraction that we started with on the last one, 1,600 over 20 or 2,000. The zeros cancel. I still get to 16 over 20, and it still simplifies down to 4/5. So this is a little bit easier way to look at it. If you already know that one has happened, you only need to look at the numbers in that row or column.